Hello learners, I welcome you all in yet another video lesson of National Institute of Open Schooling's DLED program, course code 504, Unit 1 on how children learn mathematics. The topic for today's lesson is nature of mathematics, but before moving on the topic, let me discuss with you the proposed flow of the lesson. In the beginning, I would discuss with you the lesson guide, then there are expectations in terms of learning objectives, then we will move on knowing what mathematics is as a concept, then we will discuss the nature of mathematics in terms of logical, precise, systematic and abstract science. At the end of the lesson, we will recapitulate and there is a take-home task for you at the end of the presentation. Let me share with you first the lesson guide. During my presentation, I will explain and exemplify the different concepts. You should follow my voice and the slides as well. You will find important words and sentences etc. have been highlighted to facilitate your retention. I have also summarized the main points at the end to have a quick glance for better retention. There are some questions and exercises in between, and at the end of my presentation, you are advised to attempt these questions and exercises after going through the video lesson. My dear learners, these are the learning objectives or the expected learning outcomes. After going through this video lesson, you would be able to get acquainted with what mathematics is. You would be also able to understand the nature of mathematics, and you would be also able to understand how nature of mathematics influences the learning of mathematics. The first question when we use the term mathematics comes in our mind is what mathematics is. Is it only counting? Is it only measuring? Is it only quantifying science? I think no. Mathematics is more than all these, even they are taken together. If mathematics is not all of these, then what mathematics is? Aristotle defines mathematics as the science which shows up quality with respect to forms and local motions, seeking figures, numbers and magnitude, and also place, time and similar things. It can be conceived through senses and without senses. Mathematics is a science which can be understood and experienced through the senses and without using the senses, that is through logic and reasoning. Aristotle also further defines mathematics as a science of quantity. There are some other definitions also which defines mathematics. Oxford English Dictionary in 1933 defined mathematics as the science which investigate the conclusion implicit in the elementary conception of spatial and numerical relations, and which includes as its main division geometry, arithmetic and algebra. The Encyclopedia of Mathematics defines it as a science of structure, order and relation that has evolved from element of practice of counting, measuring and describing the shapes of the object. To consolidate what mathematics is, there are few points. We can say comprehensively that mathematics is a science which is more than just arithmetic or algebra or geometry. It is a problem posing and problem solving exercise or activity. Mathematics can find and study patterns and relationship. It's a language without ambiguity. Yes, my dear learners, mathematics is considered as the most scientific language which doesn't have ambiguities and doubts in it. Mathematics is a path of independent thinking. It facilitates and promotes independent thinking. It is also a way and a tool of thinking, as mathematics is language and we all understand and know that language facilitates our thinking. Therefore, mathematics can also be considered as a way and tool of thinking. Mathematics can be considered as a changing and expanding body of knowledge. With the addition of new knowledge, it is ever expanding. Mathematics is a subject which is useful for everyone, and it is used by everyone in his or her day-to-day life. When mathematics is such a great thing and such a wide subject, then we are required to know about its true nature. Primarily, mathematics is considered as a science which is logical in its nature. It also seeks precision in its process and system. It is also a systematic science which aims at abstraction. These four things are the basic qualifying parameters which explain the nature of mathematics. Coming on the first point, or the parameter, that mathematics is a logical science. Mathematics is accepted as a branch of logic by C.G. Hampel, which exemplifies that all concepts, whether it is of arithmetic or algebra or analysis concept, can be defined in terms of concept of logic. Otherwise, it also means that logic is an invariable part of mathematics and learning of mathematics. There are two kinds of logic which are involved in mathematical logic. One is inductive logic and one is deductive logic. Induction and deduction are the basic process of mathematics on which the mathematics operates, and these basic processes operates on the logic. Therefore, we have categorized the logic into two, the inductive logic and the deductive logic. Look at the proof which is there on your screen. There is a statement which says that two even number when added together give another even number. Can we prove it only through observation? No. It requires to take several examples to prove its generalization. That is, it's a deductive logic. We are moving from a general statement to specific examples to prove that particular statement. Deductive logic is the basic logic which is involved there in the mathematics. When we solve problems by using theorems and axioms, we are using deductive logic in mathematics. Now comes the inductive logic. Look at the proof which is there on your screen. I have given four equations. In first equation, 2 plus 4 equals to 6. In second, 6 plus 8 equals to 14. In third, 2 plus 6 equals to 8. And in fourth, 12 plus 6 equals to 28, so on and so forth. How can we draw a generalization from these specific examples? If we are drawing a generalization from this specific example, we are using inductive logic, that is, we are moving from specific to general. We can draw a logic, an inductive logic or a generalization from this example as two even numbers when added together give another even number. So, mathematics is invariably logical in its nature. There is an exercise for you which I would expect to think by you or think over it. There is a statement given on your screen. Every prime number has two factors. You are required to think about the kind of logic to be used for proving this statement. Moving towards the second characteristics of the nature of mathematics, that is, mathematics is symbolic in its nature. Being symbolic in nature refers to according symbols for converting problem in clear and precise format, which mathematics does to solve and communicate them more precisely, more accurately and more finely. There are some examples given on your screen. Look at the first example in which there is a statement which is we simply use in our day-to-day life. 200 when multiplied by 10 gives 2000. It's in broad statement, it's in big statement. When we convert it into mathematical expression, the second point comes, that is 200 in numerals with multiply 10 multiplication symbol equals to, with the symbol of equals to 2000. It concise and make the expression more precise and more communicable and more comprehensible. Look at the example 2 on your screen. There is again a statement where it is referred 10 is greater than 5 but smaller than 15. When it get converted into mathematical expression by using the lesser than and greater than symbols, it is converted into the sentence second, where 5 is less than 10 and 10 is less than 15. This expression make the statement more clear and precise and comprehensible in nature. There is another example on your screen, just have a look of it. Another statement which says, then when the sum of two natural numbers a and b is squared, it gives the sum of square of a and b added with twice of the product of the two numbers. Isn't it confusing? Let's convert it into a mathematical expression. We can write a plus b under bracket whole square equals to a square plus b square plus 2 under bracket a plus b. It makes the expression more clear. Now, there is an exercise for you. You are required to think, when the subtraction of natural number b from a is squared, it gives the sum of square of a and b subtracted by twice of the product of the two numbers. You are required to symbolically represent the statement given above in terms of a mathematical expression. Coming on the third characteristic in the nature of mathematics, mathematics strives for precision. Mathematics is a precise science. Precision means accuracy and exactness, and mathematics aspires for accuracy and exactness in its process. Take an example of any of the mathematical concept and you will find that it is clear and precise and also complete. Precision has three qualities: its clarity, its exactness and its completeness. There is an example of a circle. Circle can be defined as a two-dimensional figure drawn through taking a center. It has a radius which can be referred to as r. It also has a diameter which can be referred to as multiple of twice of r, that is 2r, a circumference which is expressed as 2 pi r, and a area which can be expressed as pi r square. Isn't it a complete definition of a circle? Now look at the example 2 where the square is defined. Square is a plane figure with 4 equal straight sides, can be referred as A, and 4 right angles. Right angles mean a 90-degree angle, having perimeter as 4a and area as side square or a square. Isn't it a complete definition? Isn't it a precise definition? Isn't it a exact expression or to make an imagery of what a square is? Look at an example 3 on your screen where I have defined pi. Pi is a mathematical constant which has an equivalent numerical value of 22/7. It gives a clear and exact definition of what pi is. Therefore, it can be said that mathematics is precise in its nature. Precision in mathematical concepts enables understanding of the objects in real life more clearly, more accurately. Precision leaves no scope for ambiguity and doubt. Therefore, the mathematics is considered as the more clear language. By using which we can make our life easy and we can make our life comfortable. Preciseness also implies objectivity, certainty, correctness and completeness, which is also useful for us as a human being. We aspire in our perception to look at the world in a complete format, and here mathematics help us. Preciseness can be best learned by making comparison as a method or by using comparison as a method with our children. Children should learn to identify and appreciate the property of preciseness in the mathematics, and it is the responsibility of a teacher to make his or her children learn to identify and appreciate the properties of preciseness in mathematics. Now, moving towards the 4 characteristics in the nature of mathematics. Mathematics is a study of structure, or it studies structure, which means that it studies arrangements, composition, configurations, order, form or systems. Or we can understand that it studies broadly the arrangement of knowledge into different structured sets to be used in predefined manner while carrying operation. Think about any set of mathematical concept. You will find a structure in it. For example, I am exemplifying or giving on screen the hierarchical structure of a number system in which the set of number system falls at first step, then the set of whole numbers falls at a second step, then the set of integers falls at the third step, and then the set of rational numbers falls at a fourth step. So, it can be said that mathematics is a study of structure, and every mathematical concept has a structure in it, and by applying those structure we can study and we can understand the structure and in operation and processes in our life. Now, it's a time for task for you. Identify the structural hierarchy in which the two-dimensional geometrical shapes can be organized. You can think about the structural hierarchies in which the two-dimensional geometrical shapes can be reorganized or categorized. Now coming on the 4th property under the nature of mathematics, or the property of mathematics. Mathematics aims at facilitating abstraction. Abstraction refers to concept being apart from the material object, or abstraction can be understood as the thing or as a phenomenon in which you cannot sense or experience anything directly through your senses or by using your senses. You need to use logic and reasoning to understand a particular phenomenon, and this is called abstraction. Abstraction use symbolic representation to concise the problem to make it more comprehensible. Abstraction, or the quality of abstraction, is aspire to develop children's observation to understand the phenomenon around them symbolically without concrete representation, as abstraction facilitate quick learning and is exhibited during the high levels of cognitive development. There is an activity on the screen for you. Ask your children to sort the object in a bowl which contains 4 different kind of objects together, and then ask how they made the sorting, and you will find that they first observed and compared all the objects in the bowl in terms of their attributes, say color or shape. The children first look at the objects which are there in the bowl before sorting, and they will first comprehend or observe and compare their different attributes or which are making them eligible to fall in different categories, and then on the basis of attributes they extracted the objects and placed them in categories. This is determining quantity before. After observing and comparing the objects in the bowl on the basis of their attributes, the children extracted the objects and placed them in the categories. This can be understood as observing the quality first through reason and logic before actually determining the quantity, and the whole of this exercise is done on the basis of aspired abstraction by human being or by the children. Abstraction is an amazing feature of mathematics. There is a whole branch of mathematics which is devoted to abstraction. It is called algebra, and algebra is sometimes called as abstract mathematics. Abstraction can also be understood as means of encompassing wider range of application of mathematics. To sum up, in today's lesson, we have discussed that mathematics is a science of structure, order and relation which is logical, precise and systematic in nature, aiming at abstraction. Mathematical statements consist of a series of logical arguments applied to certain accepted rules. Precision deals with accuracy and leaves no scope for doubt or ambiguity, and hence mathematics give precise solution to the problems. Mathematics is elegant and precise, and mathematics learning aims at abstraction, that is to enable its practitioner to look at the set of objects classified and identify the scheme by which the classifications was accomplished. The very nature of mathematics facilitates its intrusion in almost all the sphere of human life. Now, it's time to take home exercise. I expect you to devise a strategy for developing concept of triangle among your grade 3 students. With this, I'll leave you for learning and teaching of mathematics. Thank you all. Thank you very much.